Okay, it's 5 minutes after. I think we could start. Yeah, welcome to the training Advanced 2. And as far as I know, the last training for this year. Yeah, let's get into it. Let me introduce myself a little bit. My name is Kuemmel. I'm Java developer. And most of the time, I'm involved to the MicroStream cluster development and also on some Allianz and Fraport projects with the EclipseStore and MicroStream. And sometimes I'm also trainer and conference speaker. Yeah, that's all about me. So let's have a short look to the timetable. As always, we start at 5 or 5 minutes after. And we will have a short break somewhere around 8:30 or 8:45. It's always a little bit different till 9. We will see. We are not that much people for today, so if we are good a little bit earlier, so that's okay. It depends on your questions and so on. But be sure I brought a lot of interesting projects for you for today. And that brings me to the topics for today. So as always, we start with a small warm-up project exercise, and we will do it also together directly from the beginning. So I go through step by step and cover all the topics from the previous training. So that means we talk about lazy loading, backup configuration, transactions and rollbacks, and so on. All the topics we had in the Advanced 1 training. Then another new topic is the housekeeping. We already talked about this in Advanced 1, I guess, but more in detail and also with an example we will go through today to talk about the housekeeping. And then a very new topic, I would say, is the GigaMap itself. So it's close to the release of the GigaMap. That means I've talked with my colleagues and they said the alpha version will be released on Tuesday next week. And that allows me that I can show you the GigaMap, how it works and what is the idea behind and so on. That is a great thing I'm able to share with you. Then we have to talk about exception handling. This is nothing new. We already covered that in Advanced 1 or 2, but it's always a big issue and a big topic. And that's why I want to talk about this again for today. It's just a small one. It's just about shutdown on error and gracefully shutdowns and so on. So that's a small topic, but an important one. So one of the main topics for today is concurrency handling. We always have this topic on Advanced 2. It's all about concurrency in general in Java because it's important, especially when we are working with EclipseStore and some solutions. Then that brings me to the customizing part. So there are some adjustments you can do using customizers. And last but not least, we will go through the MicroStream cluster and we talk about what is clustering, how clustering works, how the replication works, and all stuff around the software as a service platform that we provide. That is the last part of the training for today. So, of course, question and answers, and that brings me to some further information. The material sessions are recorded and you will get access after the training. It took around, let's say, 5 to 6, 7 days. It depends on if there are any public holiday or something like this. So you will get access and you will also get access to all the code or to all the JIT repositories that we have within that training. So you can go through all that stuff also later. Questions, that's important. Ask as many questions as you can. That's why we're here. And that's important for you to understand what we are talking about. And yeah, there are some further links. And I'd like to share these links with you. I do this every time. So Let me just copy this for you. So, just a second. So here are all the links you need to have to. Okay, and last but not least, the certificate, this is also included. So it's the same like the videos. Normally, you will get access to the certificate 5 to 6 days after the training within our cloud platform. It looks like this. Here we are. So it's cloud.microstream.one. And here there is a certificate section. And when you will find the certificate here, and after clicking on the I button here, you will see a certificate, you could download it and so on. And one important information you need to know, you have to register there with the same email address like you attend here to the training. And if there are any differences, please let me know. Then now I'm able to take a note of that. So because normally I go through your names and I see, okay, you are invited with a specific name, and it's necessary to map your name to a specific email address, and then I will enter it to the application, and after that you will be able to see the certificate. But it's important to use the same email address like you attend to the training here. Okay. So let's go on. Yeah, cloud microStream.one. We already talked about this. Okay, any one of you, or for some of you is it the first time that you are here? So let me summarize MicroStream again a little bit. So as always, it's a Java framework. It's a from scratch invented object serialization. And the special thing is we are able to update the serialized part on the storage or on your hard disk or whatever. Most of the data stays in, or basically all the data is in memory except the lazy parts, and there is no data mapping or mapping annotation at all. You just need your pure Java POJOs, and that's it. So it's kind of like changing the data in the RAM, and the MicroStream or EclipseStore takes care about to keep RAM and storage synchronized. So that's it. Just a small summarization of what MicroStream on EclipseStore is. Okay, any questions so far? Oh, I missed. Before we get into the exercise or the exercise. Okay, so as I said, let's start with a small exercise on that training. The project itself, it's the MicroStream Training Bookstore warm-up project. So let me share the URL with you. So that's the link where you can find that project. And there are two branches. One is the main branch. That's the branch we are starting on. And there is another one which is called Implementation Done. And yeah, surprise, it's the branch where everything is already in place. And that's it. Let's talk about the requirements that we have to do. So we have to complete the following classes. The DB class, it's the storage manager itself. So it's the instance of EclipseStore at the end. And we need to complete the book controller. I think that's nothing special, but let's see. We have to use the builder pattern to initialize the storage manager. Okay. So we need two channels. We need a store target, which is called data, as always. We need a backup. That's new. But yeah, that's a topic from Advanced 1. We need to set a lazy clearance to 10 minutes. That's interesting. We talk about this later. And now it becomes difficult. So we have to create an index for books, the first 2 digits of the ISBN. So that means we need to implement this the lazy way. And we talked about those index solutions. And that means we need somewhere a hash map to create an index like this. And another add is we always need a full list of authors. Even when the last book of a specific author is sold. We also talked about this in the last training, and that's okay. We should add a transactional behavior within the update multi-books method within the book controller with a rollback functionality. Okay, let's do so. At the same time, the last point here is also a topic I want to cover within that training, and that fits best. Do it exactly at the end of the project, then this is also covered. Okay, so let's start with the exercise. Okay, that's the project. So I already opened it. It's I'm on the main branch. And if you want to code along, feel free, do that. So I will take my time, so then it's slow enough for you to code along. Okay, let's go through the classes that are already in the project. So there is within the resources, we see the JSON files for some mockup data, and that's all we need to know about this. There is one class, which is the DB class. It's already opened. This is where the storage manager will be initialized later. There are some domain classes already in place, and there are already filled. So we have an author, we have books, ISBN name, release, price, and so on. And there is one root object, and it's also empty, that root. So that means we have to create our own root structure. So as you remember, we need one root object on top of the object graph as a step in or entry point to our graph. When we want to access the data, we always go through the root object to a specific part of the object graph to get the data. Okay, so that's the root. And there is one book controller, and you see there are some lines, enter your code here. So we need to add some further implementations here. Yeah, let's start with the DB class, I would say. So just a second. Okay, so DB class, here we are. So what we always need is one instance of our storage, and this instance is represented by the embedded storage manager object. So let's create one. Let's say public static embedded storage manager. It's always the same. So we need it. Only in some other examples, you will get a different one. So for example, when we talk about the cluster solution later this day, then we will use a different one. Then we need the cluster storage manager. But for now, for the embedded storage, we need the embedded storage manager. Or let's call it storage manager. And we need another element. Yeah, final root. Let's call it root equals new root. Okay, so this is one instance of our root object. And of course, the embedded storage manager could also be final. That's also okay. Okay, so we need to initialize it. So okay, that will not work. But it also could be. Okay, so let's use the static block to initialize these elements. Let's start with the storage manager. So let's say storage manager equals. So normally we use the embedded storage configuration dot builder to this enable us to use the builder pattern. And now we could create all the things, or we can do all the configurations that we want to do. So, and we start with the channel count. So we say set channel count 2. Let's move on. We need to set the storage directory. So, and we want to have a data folder. And when you use it like this, the data folder will be created directly within your project. It's not the way doing this normally. Normally, you will have an external path to store this, or a mounted path of a persistent volume or a Docker volume, whatever. It's only for the training that I use data here to have it the simple way or the easy way to see it's created here, and it makes the training a little bit easier. So, but it makes no sense in the production way having the data folder within the project. So whenever you redeploy your project, you will delete the data folder. That doesn't make sense. Okay, set storage directory data, and let's create another directory. Backup directory. That's what I'm talking about when I said, okay, we need a backup directory. And let's call that directory backup. And it's the same here. It's also created within the project structure. But for the training, we are totally okay with that. And yeah, okay, that's all we need. All the configurations that we have to do. So we set the channel counter to, we created the data folder and a backup folder to write the Miro in. So after that, we normally create our embedded storage foundation. Based on the foundation, we create the storage manager. And here we have to add the root object. You should not forget this. That's an important move, to add the root here, because this will lead to an error which is quite hard to find. So when you forget the root here, it seems that it's working, but after a restart, the storage is empty again. So it's important to add the root here. And another important step is to call the start method. So that starts the instance of the storage manager, and that starts the storage, I would say. And when you call the start method, then the already existing data, which is on the hard disk, will be loaded to the RAM at the moment you pass the line 22 here with the start call. Okay, so good so far. So far, so good. We need to add some more stuff here, but let's do that a little bit later. Okay, so let's move on to the root object. The root is already empty. So let's do this within the next step. We talked about that we need to have books in our storage, and we had to create an index based on that books. And in that specific case, let's create a private final map. And that map consists of a string as a key. And we want to have some lazy stuff here. Oh, come on. So lazy. And it's a lazy list of book. Okay, so for just to explain that a little bit, the target is having the first 2 or 3 digits of the ISBN here as a key identifier, and then a list of books here for two reasons. You remember maybe when collections are growing and growing and growing, that leads to a lack of writing performance to that collection, because we have to store not the whole collection always, but some parts, and that reduces the writing performance the more the collection is growing. And that's the first point. And the second point is, when we are looking or when we're searching for a specific book, we do not have to open the lazy list of books at once, and that helps us to just load a small chunk of books, especially when we're searching for a specific ISBN or something. Okay, so let's call it books equals new hash map string lazy books. That's it. So this is how we want to store the books. So when we come to the GigaMap example, you will no longer need this anymore. So, but let's move on. So we also said that we need a special map of authors. And for that reason, we use a string and a lazy author. So that means each author is lazy loaded. Authors. Let's call it, oh, come on. So new hash. Okay, why do we use stuff like this? So we will see what happened here later, but we doing the author also in the lazy way. Reasons for that could be maybe an author consists of, let's say, 10 or 15 images, for example. Then it could make sense having that author the lazy way. I don't know. It's totally up to you. It's the string itself could contain multiple, let's say, valuable, important informations to search with the author.
Would we have only one author?
No, multiple ones. But we could have multiple authors in here.
Yeah, it's a map. Yeah, so sorry.
And then we could have multiples. It's just an example for you to see what's possible basically. Okay, let's create some get and set methods. Oh, that's the wrong one. That's what we need. And that's it. So 2 collections, 1 for the books, 1 for authors. And when we have a short look to the book element itself, you see there is also an author inside the book. But that's also the reason. So that's what I said, or what I explained, when you remove the last book from the collection, you will lose the author also. And that's why we have the authors in an extra hash map here for combo boxes to search for it and so on. Okay, so that's it. And let's move on to the controller. So also and book. Is it different? Setup data. Is it the same controller? Am I in a different project? Create single book. Ah, okay. It's renamed. Okay, it's different to the thing. Okay, doesn't matter. It's the same code. So that means that mockup utils class creates a list of books based on the 2 JSON files down here. And let's stream through these books. And me just double check. Okay. So let's stream through the books and let's call for each. And let's say for each book, we want to come on, like this. Okay. So, and now it's a little bit difficult to add, or a little bit more difficult to add something. And that's also the reason why I stream through each book, or just streaming through the books like this, because we need to create the index, right? So, and that brings me to the first line of code. Let's say dv.root dot. Oh, just check. Did I forget something? Oh, I think that the get and set methods are missing. Okay, so now that's that should also work without that get and setters, right? So it's public. So what's wrong here? So root dot okay, get books. So that is what we need. And now we use that method, which is called compute if absent. It's a method that is provided from the hash map. And now we have to add the string to search for a specific, let's call it chunk or a specific key. And for searching to that, let's say b.get ISBN dot let me substring. Let's use substring 1, 2. Let's use the first 3 letters. So that means we are searching the already existing hash map for that this 3 letters. And if you find it, then it's okay. And if not, and this is the second part here, we create a new list of books. This looks like this. So that means we create a lazy dot reference of a new empty array list. So let me just move this a little bit to make it more understandable. And this is the point which is returned at the end. And then I could say @b. So, okay, there is one. Let me just check if this is that's the stream. Did I miss something here? New array list. 3, that should be okay. Compute if it's center. There is one small thing which is not working as expected. So let me just copy paste this. That should be okay.
I think it's just missing the dot. No, you had the dot. Sorry, my bad.
Yeah, I copied it. So now it's okay. So I copied this from the repository. So now it's okay. Okay, so compute if absent. I explained that method a little bit. So it searches for a specific string, and we said we need 3 letters here, and lazy dot reference if it's not in the map. So then we create an empty one, and we return that empty one and with get. And after that, we add the book to the new lazy reference. And if it's available, if the key is already in, we get the already existing ones. That's how it works. Sometimes a little bit confusing, also to me. And we're doing the same with the author. in a different way. And let me just copy paste this. That's the part for the author. This is how it works. So it's the same for the author, compute if absent. And now it's a little bit different. So now I use just a string for indexing stuff, ID, the email address and last name, whatever else. It's totally up to you creating an index here. And on the other side, on the value side, we have the author element. And that's how it is inserted. I would say there are 1,000 different types of or possibilities to create objects like this, or creating an index or whatever. You will see a much better solution on the GigaMap then. Okay, we need to store it, and therefore we call our store method at the end. Let's say db storage manager store all, and in that case I have to store the books itself and the authors, and yeah, that's it for this method. So this is just for adding mockup data at the beginning. We store the collections itself. It's always the same with EclipseStore. We have to store the element which has changed. And in our case, we always change because we add something. So that means we change the collection. And that's also the reason why we have to store the collections. Okay, create a single one. So these are the two authors and book which is created. And let me just copy paste this. Mostly it's the same code like on creation. It's the same, and it's also the same on the author side. And that's it. So yeah, I have to change this for the next training because that's really totally the same. So that doesn't make sense that much. So okay, starts with 1. That could be interesting. So ISBN starts with 1. So let me just start with that. So db.root.get books. Let's call the entry set and stream through it. That's the beginning. So then we have to say dot filter. So we need to filter the key. Oh. So s dot get key dot starts with 1. So that means we want to have all the ISBN entries that starts with 1. And because we have collections on the other side, we need to use the flat mapping. So map it to one single collection. e.get value dot get, because it's a lazy. So e.get value, you will get the lazy element. And when we call the get method, you will get the real collections at the end. And we have to stream through because we have to collect them later to collect. Collect, yes. I missed the dot. So collect collectors dot to list. I know from the last training we talked about that collect and collectors to list. I wasn't able to check this so far. So, but we need a return here, and that should do the trick at the end. Just a small example of using the filter, and so on. Okay, that brings me to the last. Method, the update multi, and I want to do the transaction and rollback stuff also here. So that means update multi books. Let me just check what is the. Okay, we want to set the price on the books we searched by starts with 1. So that means each book that starts with ISBN 1, we want to set the price to 50 euros or whatever. So how could we do this? At the beginning, we create a store. So we just changing one or multiple books, but it's a single entity, and therefore it's enough using lazy store, because there are no changes in any deeper sections of a book, or there are no sub entities or stuff like this. So that means we could call db storage manager dot create lazy store, because we only want to store the first layer of an entity. So lazy store, let's call it ls. It's the lazy store. Then we need the list of books that starts with 1. So, and therefore we use the method here. These are all the lists we want to change. And then we add a try catch around this. And in case of anything else goes wrong during the changes. And now let's see what we can do within that. Okay, so let's move on. Is starts with an A dot for each book. Let's say b dot set price to we need a new big decimal. Let's say 50. Okay, and we need to store it. So I would say not really store it, but we have to register this to the storer, and therefore we call ls.store. Yeah, as I already explained, this is a little bit misleading, I would say. Sometimes we are thinking about to change this, change it to register, but it's a change of the API. It's always quite difficult. So, but okay, so store means in this case B is registered on the storer to be stored later on. So when we go through all this stuff here, at the end, when everything is all right, so we can call ls.commit. And then this is the moment where all books or all changes goes to the persistent storage on your hard disk. But in case of something goes wrong, we have to take care about here. So of course, we do the easiest thing. We say, okay, print stack trace, of course, but now we have to do a reload at the end. And therefore, we provide a reloader. Reloader.new. And we need to hand over the db.storage manager persistence manager. And that creates a reloader element. So let's call it reloader. Here we are. Okay, so now we can use that reloader element to restore or roll back the values that we have changed. So, and the easiest way is we use that method like this. So we go through the ISBN, starts with an A, starts with 1, sorry, dot for each. And let's do it for every book. Reloader dot reload flat, because there are no changes on a sub element. It's just the changes within the book. And let's do the reload here. After that, we could return a specific error, but that's just a micro now thing. So let's return an HTTP response. Server error, books, update books failed. All changes are rolled back at the end. And that's it. This is like transactions could work with EclipseStore within your projects. So that reloader gives you the possibility to reload, to resync stuff with the storage on your hard disk. And in some cases, and that is quite important, doing this. Okay, so that's it for the controller class. A lot of stuff is going on here, but I think it's not that complicated to understand. We talked about this also in Advanced 1 training, so that most of you should already aware of this. Okay, so any questions so far from your side to this example? So I saw that some of you are joining late. Hello to everyone again. Sorry for not recognizing you during the explanation, but but I try doing my best to see you in the waiting room to let you in. Okay, so let's move on. There are some smaller things we have to implement here on that example project. The DB class, there was one thing that we have to add, and it was the lazy release that we have to do within the DB class. So we want to change the default behavior of the lazy release thing. And we could do doing this by adding another one. So that means we adding a lazy reference manager. So let's use lazy reference manager.set. And let's do it like this, lazy reference manager.new. Oh, come on, .new. And let's stay in here. So, okay. So let's create a lazy dot checker with a specific duration, and therefore we say duration. Not sure if it's a Java time duration. It is, yes. Dot of minutes. Oh, sorry. Of minutes. Let's say 10 minutes. So that means we are changing. We are changing it to, so that means when object stays in memory untouched for 10 minutes, they will be released at the end. And let's say .2 millis. That's it. So doing that the right way. So let's say .start. Okay, hopefully I did it right with all the brackets here. Okay, here we are. So that means we just set a new lazy reference manager, and we create a one here with a specific new duration of 10 minutes to release the lazy references. The default behavior is 30 minutes, and we changed it to 10 minutes. This line or this code has to be always before initializing the storage manager. That's important. Just have it before initialization. Otherwise, it will not work.
Christian?
Yeah.
That was my question. You already answered it, but can you please explain why that is?
That's a thing deeper of the API. I'm afraid I'm not able to answer this exactly. It's because of the API is designed like this. it's not my decision, but yeah, it is as it is, I would say. Not a specific reason from my side, but it's a good question. I will take this question with me. Let me just take a note, and I will try to find it out to the next training. Okay, so
Please note, if I would have done it, that would definitely be a hassle to think out that it would be the first thing to do instead of assigning the embedded storage configuration to the storage manager. I would have definitely done it otherwise.
Okay, so and I will bring it to the next training. So it's also interesting for me, but I asked my colleagues a long time ago why it is the case, but yeah, I couldn't remember. So it's the API is designed like this, but yeah, okay. Good so far. DB class, root, books, author, controller class. We are good to go, I would say. Let's try it out. So just to be sure, I will just switch to the next branch. Or come on, let's try it out here directly. So bookstore warm up. So let's make a Maven update. To start the application, we have to go to the application and just call run as Java application at the end here. And as far as I know, these are all get methods. So that means we are able to call this within the browser. So you see, Micronaut, the application is up and running. By the way, if you want to start it also within your IDE, you have to enable the annotation processing of Maven. So otherwise it will not run. So before clicking on run as Java application, enable the annotation processing of Maven. Okay, so we can reach the application on localhost 8080. So let me do this on the second screen. And localhost 8080. Oh, there is just a second. There is a storage already in place here somewhere. That's a different application. So we are bookstore warm up. Yes. Yeah, see that? There is data and there is a backup also, and that leads to that error. Okay. So again, okay, now up and running. So localhost 8080. Let me just double check. Let's call books.create /books/create. Oh, okay, book successfully created. Let me check if you're able to create single. We don't have one get method. That's interesting. So books create single update multi. Let's call that update multi. There is something wrong, I guess. Okay, let me just switch to there is something I missed at the end. So, okay. So, these are changes. Let me replace this and switch to implementation done. Okay, let's just double check if there is something really different here. Ah, I see. Okay, that's why I removed. That's the reason why it's the naming was different. Okay, but the code seems to be the same. Create single. Okay, let's try this. So I'm just wondering why there is no method to show some books here. But that's not that important. So let me start this. Oh, maybe let's do a Maven update just to be sure. Okay, here we are. So create. Localhost 8080 books create. Ah, okay, of course. It's named set updater now, not create. Ah, so let me just delete. So this is by the way not interesting situation. You see that we created a backup. Right? So when we started, and this is always one situation which leads to a failure, because most of the time I delete just the storage itself and left the backup as it is, and that's a big issue, because when you start the application again, the backup and the normal storage are not in sync, and that's the problem, and that leads to that error that the application will not start. So that means you always have to delete the backup and the normal storage, because they are otherwise they are out of sync and the application will not start. But that's also an interesting situation. So okay, again, so let's use debug. So okay. See that we have to check that error, but I could remember that instance already exists exception. I think that was an error. I want to check this. Last time it was the same. Yeah, I have to check this. What is the reason for this? Maybe instance already exists exception. Okay, I have to check this, but let's try the update. Okay, so I get the message books successfully updated, so that works. And yeah, I think that's all. So there is no get method. Maybe we could add something. So but it took us too long time. I will add a get method to the next training. So or to the repository after the training. So you will see that get method after at the end here, down here. Then you could check it out and see what's going on within the storage itself. Okay, so but the basic stuff we implemented here, it's okay, so we can use it, and it's just for repeating the stuff from the advanced one training. Okay, so let me just check your questions if there are some. Is there a proven function to remove the data files automatic before start of test methods? You could create one based on Java. It's not a function that we provide from EclipseStore, but it's a good idea. So yeah. Let me take this with me. It would be also a good suggestion for the GitHub discussions to always create a new storage. that could make sense. But let me just take a note. To delete storage. Okay, that could make sense, especially for testing. Yes. Okay. Some more questions so far. Then we will move on. Okay, let me clean up my desktop a little bit. So I have to check. Yeah, let's move on with one configuration topic, which is mostly part of the Advanced 2 training. It's the housekeeping process. I brought one project, which is named MS Training MicroStream Configuration. And that's a project I used also in the Fundamentals and Advanced 1 training. And in it here, there is one branch which is called Housekeeping example. So let me share this with you. Here we are. So that's the project itself. And as I said, there is one branch. It's called Housekeeping example. And I just have to start that example. And I have to check if there is a storage already there. No, it's empty. You can see it here. There's no storage. And let's jump into the controller just to see what's going on here. Now, okay, that's interesting. So there is one method which is called create, and it streams through. It's the same method here to creating mockup data of books. And in this case, I iterate through all that books, or I iterate 10 times. So we could increase this a little bit. Let's do 15 times. That gives us more time to see what happens in that folder at the end. So that means we iterate 15 times here, and on each iteration we creating that, yeah, let's say, I don't know, 1,000 books, I guess, and we store it, and that's it. And as you can see here, I do the store directly instead of using that store object with store and commit and so on. So that means on each iteration, I call the store method just to simulate a situation where you send, let's say, logging data to EclipseStore, or to simulate a heavy writing situation to EclipseStore. Okay, so let's start this and let's see what happens in the end. So we need the application here and run as Java application. So Micronaut is up and running. So let's call localhost books.create. And now we should see the data folder here. System Explorer. Hopefully I'm fast enough. And now you see what's going on here. That is the folder. And you see that the folder is growing and growing and growing. So now we are on the 13th iteration, 14, 15. But you see the folder is growing more and more. And the reason for that is that the frequency of writing data is such a high frequency that the housekeeping process is not able to do a cleanup during the writing requests, and that's a real problem. So that means if that leads to, you see, and this leads to a huge amount of data on your hard disk, and if this happens for a short period of time, that wouldn't be a big problem, but because at the end, EclipseStore will clean up this later, that's okay. But if this situation goes on and on and on, it will lead to an error, storage failure, or whatever. And we have to fix this. So, and the one situation to fix this is to increase the amount of processor time for the housekeeping. And let's jump into the configuration here. So that project is configured via the XML file. And you see that I added 2 lines that I'm able to activate. And I increased the housekeeping interval to 400 milliseconds and the time budget to 100 milliseconds. That means the housekeeping itself has more time budget doing housekeeping at the end, and it is more often repeated, I would say. And let's stop this. Let's delete the data here. And let's see what happened at the end on the hard disk. So project is started. So on my second screen, I call the books create method. Not sure. Let me just check. Books create. Is there something I missed? Okay, let me start that again. Okay, that's okay. So we no longer need this. Okay, as jump application. That's okay. Okay, iteration is running. So we do a refresh. Let's check that folder. System Explorer. Let's move into data. Okay, and now you see it's cleaned up automatically as expected. You see that the files are not replicated anymore, and the housekeeping doing that job. And that's the reason for that also is you have to understand how EclipseStore is working in the background. That means when we talk about storing something or changing something, EclipseStore in the background is an appended storage. That means everything when you call a store or when you call an update, everything will be appended to the end of the storage. And the housekeeping process takes care about to delete all the duplicate entries at the end. And that happens when you change the housekeeping configuration. So whenever you see a growing folder of channel files, you know, okay, it makes sense maybe to increase the housekeeping process a little bit to prevent such a behavior at the end. Okay, so just a small hint of a specific configuration. Give it a try for yourself. Try it out and start. It's quite funny to play around a little bit with that, see what's going on, increasing and decreasing. There is not a best practice approach how much, how big the values should be on the housekeeping. It's it's always depends on your methods that you use and how big are your objects are. It depends on your application. So just play around a little bit and see what's going on your hard disk, on your storage, and then you will see the result at the end if it's working as expected or not. Okay, any questions regarding that housekeeping? Okay, so that brings me to the next topic for today. Let me just clean up a little bit. So we need that data. We do not need that anymore. Okay. So as always, I prepared a project for you. And I would say it's a brand new one. So I created it today. It is named ES Gigamap example. Okay, here it is. This will not run now because the repositories are not opened yet. So so you will get an error within your POM XML when you open it, but it's okay for you to have a look and what's going on there. So I checked out. I already checked out the project itself, and it's here. Let's jump in, and there are a lot of stuff within that project. That's it's the same structure like in the ESMN setup here up there. That was the project with the Lucene index implementation, and this is a quite good implementation how to use Micronaut together with the EclipseStore, for example. And you see that because there is no DB class anymore. So there is only one properties file down here, and it creates the storage, and it's just a configuration like this. And I would say this is how to use EclipseStore best practice with Micronaut as a storage provider. And it's no longer necessary to have a DB class and all that static stuff. It's not no longer needed. So we created the root, or that means the root object is here within my storage folder. And now you see there is a different type of collection here, which is called Gigamap. And I initialized it, and that's all we need. So let's say we need thousands and thousands of, or millions of books, or even more, it doesn't matter. And the Gigamap takes care about creating lazy chunks. That means it's a lazy structure. You could compare it a little bit to that hash map that we have, but in the background, it's just a list of lazy chunks in the background, in easy words, but there is a lot more functionality behind. So and it's an automatic way how to handle lazy objects with a specific index, but that I will come to that a little bit later. Okay, just to move on, we need one data access object. Normally, this is the layer to access the storage itself. So data access. It makes totally sense having this like this. So whenever we accessing the storage itself, it comes from a data access object. The reason for that is the read-write locked. I will come to that later when we talk about the concurrency. And it helps a lot having this within the DAO. And then we have some listeners here. Micronaut startup event and shutdown event. That could also quite helpful to adding some additional stuff on startup on closing the application. For example, when we on startup, is there another one? No, well, maybe I have to refactor this a little bit, but okay. Not that important for the Gigamap. Then we have one data transfer object. That means when we add a book, we doing this via JMeter. I'll come to that a little bit later. That's just the data transfer object. So that's how the object comes from outside to our controller class. Okay, so let's move on to the domain class. Okay, that's the book object itself. It consists of ISBN, title, publication date, edition, a price, and an available quantity. Nothing really special in it, just a pure POJO class of the book. And now we have, last but not least, the controller itself. So, and this controller provides all the access elements, search for, get an ISBE and an ISBN, and one post for inserting stuff. And that brings me now, you see there are some stuff is ongoing with searching for an ISBN, searching for title. How is that possible? And that's the special thing on the GigaMap. So we are able to creating indices on that collection. And such indices I created here. There is one class which is called book indices. And in that class, some indexes are created the static way. So there is one index which is based on the ISBN index. So that's the name and of the field. And that's, by the way, ISBN, and that's also the name of, so when we jump back to the book, you see that. Oh no, it's not. It's not related to the field. So this is the relation to the field. So this is the way how to get the index out of an entity, out of a book entity. So that's one index. There is another one which is created. It's based on the title. So we are able to search within the title with that index. And there is another index that is part of the publication date. So, and maybe there are, it's possible to create much more indices. And when we have a short look back to the just a second, it's down here, you see on initialization of that GigaMap here, those indices are added to that GigaMap. So we create that bitmap indices here. And this is just one example how to use this. There will be a documentation later on to see how this works. And that enables us to add these indexes or these indices to the GigaMap itself. And there must be one primary index, and that's the identity index, and that's the ISBN index in my case. So you can run it locally, of course, but not now because the repository is not opened yet. So I think you should not be able to check out the GigaMap dependency. So you could check out my project, that will work, but you will not be able to start it because I guess you are not allowed to access the repository. Okay, so that's the GigaMap. So we need to initialize the GigaMap itself. We need to add and initialize some indices on that map, and that's it. And that enables us later on, when we come back to the book controller, to call a method, for example, DAO.searchBooks by title. And when we go into it, so we are able to query that index. So we could say, okay, root provider.root gigabooks.query. And based on that index, we are able to do multiple stuff. And for example, that just examples of searching within a string. And I use the contains, but it also could be contains ignore case, starts with, and so on. Is a lot of different stuff can be used here. And there is also a Lucene implementation, so that means we could add a Lucene index to that GigaMap. That will be all possible at the end. But this is just a small example to search for the title. And it's the same when we search for the ISBN. Contains, oh, sorry, that's the title. That's the ISBN, for example. Book indices.isbn index is ISBN. And there are some more stuff for example, limits and so on. And yeah, let's check it out. So let me just double check if there is a storage already in place. Yes, there is. I guess let's start a new one. Makes sense. So where we are, application here. Let's run this. Okay, so application is up and running. And now I will use an application which is called JMeter. We use this also on the lazy examples on the Advanced 1 training. And I created one. There is one CSV file in the background, and that enables me to create a lot of elements. So let me delete this. We don't need this. Okay. So, and I will call that post method gigabooks, and that's the post method, right? So to create books. And now when we have a look at, so we see these are the books that are created. So 12, 13,000 and so on. So we have, for the moment, we have 1,400 requests per second creating books. Let it run till 100,000. So this will increase. There are, for the moment, there are 10 threads that are firing data to the application itself. And we have around 7 milliseconds per request. Okay, so let's stop it when we reach the 100,000. Okay, that's enough. So now we have 100,000 books created. And I will use the Postman to just double check if this is the truth. So let's call the count method first. And we see there are 102,184. And now that brings us to the point, let's just search for the first 50 books within the collection. And you see all that books are now within my storage. And when we now say, okay, let's search for king, let's do this within the title. So we add that king to the URL here and create and call it send. You see, it took us 22 milliseconds to search for all the king entries within the collection itself. And you see all the different books here. Some of them are duplicated for sure, but that is and you see the more you call that, the more increasing is the millisecond part here because it's cached within the storage itself. The good part on this is that also the storage on the RAM stays slow because, as I said, the GigaMap consists of many different lazy chunks. And when data is no longer needed, it will be released automatically. You don't have to take care about this. And memory stays quite low at the end. So that's a big benefit of that GigaMap. So you will be able to handle millions of data within a collection like this. Let's search for another one. Let's search for and, for example, just to see. You see that 10 milliseconds. Yeah, there is one question. How big is the performance boost factor to the old HashMap storage method? This is quite hard to say because you could implement the HashMap in so many different ways. Yeah, I think it's more. I think I would say it's the same fast than with a HashMap. Maybe in some parts a HashMap could be faster than the GigaMap, but I think the big benefit is the adding some indices to that, having multiple indices on one collection, and that makes things so much more easier to handle. You do not have to use Lucene by yourself. You just use the indexes of the GigaMap. That's really yeah, let's say a big advantage at the end. And I would say it's the same way fast. Just try it out, give it a try, using both and see what's faster at the end. But I would say this is more, let's say this is more flexible, definitely at the end. And there is another method. Let's search for a specific ISBN here. So and use another endpoint here, adding that ISBN and send it. And now you will get one specific, and you see 5 milliseconds finding a specific book from 100,000 of books. This is a really great performance, I would say. So we could, let's choose another one. Yeah, you see that it's really fast getting the data. Yeah, I think that's enough. So there will be many more features within the documentation. It's just a small preview of the GigaMap because we finalized the alpha / beta version, and you will get access to it on Tuesday. And yeah, try it out and play around with it. It's really great to have it. Any questions from your side? Or applause, that would be also great. So because it's a really great collection. So if you like it, that's okay.
So main feature of GigaMap is are queries.
Yeah, there are queries, there are indexes you could create, a lot of features, and also one of the biggest feature, I would say, or let's try this. So let's have a look to the memory footprint. That's also interesting. So the storage is still in place, right? There are 100,000 books in it, and let me just open the JMeter, not the JMeter, the Visual VM tool. So we could have a short look to the, so many windows are open. So what's this? So we do need this no longer. So where is it? The Visual VM tool. Oh, it's always the same. I have to search for it. So here is it. Okay, so here we are. So let's open the IDE. So just a second, let's start it. Okay, so application is up and running. We see that application here. Let's have a look to the memory. So you see that there are 100,000 books within the storage itself. And when we now call a specific book, for example, so let's use the Postman. So sorry for moving that windows that much, but there are a lot of. Okay, so let's call first find a specific ISBN, or let's use the count books, for example. So let's set this. So you see, it's not increasing that much. You do not have to load the whole books to count it, for example, and that's a big benefit, I would say. Or let's just load 50 books, and you see it's not increasing that much. So also find by title, for example, let's use the end, and let's search for all the books starts with an end, and you see the memory footprint is quite low for 100,000 books. And I think that's also that's another factor, I would say. It's not only the indices and the queries and the possibility to search within a specific collection. It's also to keep the memory footprint of EclipseStore as low as possible, even if a collection has millions of entries in it. And that makes the GigaMap to a really spectacular collection, I would say.
Yeah,
there are many big advantages on it, and that's why we invented the GigaMap at the end. Okay, further questions from your side? As I said, it's just a preview for Tuesday, and then you will be able to try it out by yourself and do testing stuff and so on. And I'm pretty sure you will like it. That's for sure. Okay, this is no longer needed. And I think we are good for the break. Let's have a short look to the presentation, just to ensure that we covered all topics before break. So we talked about, or we did our warm-up project exercise. We talked about lazy loading, backup configuration, transactions, and rollbacks. We covered that housekeeping topic. We talked about the GigaMap and how to handle it. And also, yeah, we will do this after the break. So we start with the gracefully shutdown and shutdown on error. It's just a small topic, but it's an important one that I have to explain you. And then we go on with the main topic for today, the concurrency handling. And yeah.
Okay. Have you managed to found the answer for lazy reference manager? It's why it should be configured first, then storage manager.
You mean the reason why?
Yeah.
That's I tried to answer this to Repco before. I don't know the exact reason for that. It's because the API. It's because some internal mechanisms of the API. I think there is no special thing on that, but I take a note of this, and I will ask my colleagues and my developers to give me the reason why is that that important to doing that before or after. And
Yeah.
sorry, before. Yeah.
Yeah. Okay.
There are some special API mechanisms in the background, but yeah, I will try to find it out. Okay. So next topic for today, and I want to directly start with the concurrency topic, because I would say it's an important topic, and it's important to talk about. So okay, so concurrency handling. Let's go through the topics or questions that we have regarding. So first we have to talk about the different layers of concurrency for better understanding what kind of concurrency do we talk about. And then we have to clarify why it is necessary to take care about concurrency or not taking care about concurrency on MySQL in a specific way, I would say. And what are the differences between, for example, MySQL and EclipseStore in case of concurrency handling? And then we have to clarify the question, is EclipseStore itself responsible to take care about concurrencies? Yeah, we have to talk about this. And then we have to talk about possible steps to solve concurrent accesses. And I have to say there are, multiple different ways to cover concurrency problems or issues. And most of them are Java built-in stuff. But yeah, let's talk about this. Mutability, locking, and so on. We will come to that later. The first concurrency issues that I want to talk about is, I would call it the tech-related concurrency issues. And this is the exact, the only thing we have to take care about in a specific way with EclipseStore. And I want to show you this. That brings me to a project that I prepared. And let me share this with you. Concurrency. So that's the repository for it. And we want to start at the branch on the master branch. I think that's okay to start directly on the master, just to give you an idea what could happen when you're not caring about concurrency. So it's just a really straightforward project. We have book controllers and books and authors, always the same. We have mockup utils and so on. And when we have a short look to the controller itself, we see that there is one a create books method, that's okay, for creating stuff. And there is one which is called iterate. So, and this method is iterating through the created books all the time in the background. So it's iterating, and so on. And it, at the end, you will get sys out. So we will call this, and let's see what happened when we iterate through it. And after that, and during that, we try to delete a book out of that collection. So let me start it. Okay, again. Now that looks good. So let's call the books create method. Okay, now books are successfully created. And now we go through, now we iterate through that books. So let's call books dot or iterate. So now the application is running through the books all the time. And now let's try to delete a book from that list. Delete book. And that's it. That's exactly why you should be aware of concurrency, because otherwise you will get a message like this. Just a second, like this one, a concurrent modification exception. And this is what I'm talking about when we talk about tech concurrency. That means a lot of Java collections are not thread safe. That means when you iterate through a collection and you try to delete something during that iteration, you will get an error message like this. And the reason why this tech-related concurrency is so important for EclipseStore is because we are operating all of the users of an application server, or all the users within an application, are working on the same object model, right? So we are talking about working on the same object tree on EclipseStore. And that's the point, because many different users are operating on the same collection. It could be. So the truth is, so I did project with EclipseStore for the last 5 or 6 years now, and we only have 2 or 3 situations where this could be where this problem comes into play, because EclipseStore works that fast in the background. So each access to a specific collection is a very fast atomic operation, and you will need really heavyweight traffic like we simulated here on a specific collection that you will get that error message. Normally, when you slow down the accesses a little bit, you will not be able to replicate that exception. And that's why at one side, it's important to be aware of technical concurrency. On the other side, it's not always necessary to have that, because you will not have that heavy writing access to your collection anyway. So, and this is the reason why we have to talk about this, just being aware of that, because this could happen at the end. And I will give you some ideas how to prevent this. Okay, so this is what we've seen in the console. But there are another business-related concurrencies. So, and I think that's a quite popular example. There is a customer having an ID 20, last name Doe and first name John. So the user 1 changes the last name from Doe to Baker. A second user changes the first name from John to Mike. User 1 stores this. That means it stores the last name, or it changes the last name from Doe to Baker and stores it to the database. And the user 2 stores the customer also. And the problem on that situation is that we always store or write a whole row of data, always. So that means user 2 is not aware of the change that user 1 did. And that's the reason why at the end you will have the result 20 Doe Mike, because the user 2 overrides the first change of user 1. Okay, this is quite a popular example. And that's also the reason why all the relational databases provides kind of like locking mechanisms, or an optimistic strategy that is provided by Hibernate, for example. And it's the same on EclipseStore. You have to find your optimistic strategy to prevent such a business-related concurrency. And that's why I've talked about. So we talked about technical concurrency issues. And this is a business-related concurrency, right? So this is not really a technical stuff. So because that's one example. Now you might say, okay, all the relational databases did that or solved that for me. But on the other hand, there is a second example, and it's also really popular. And this is what no other relational database is solving. So for example, a car selling company, and only one car should have a 20% discount at a time. So that's the situation. And then user 1 calls get discount car method, and he will get a result of car 1, get discounted car. User 2 calls also the method get discounted car, and he gets also the result of car 1. Then user 1 calls the set discounted car 2, so car 2 as a discounted car. So that means now at this situation here, car 1 is discounted and car 2 is discounted. And then user 2 calls set discounted car to car 3. And that means just right in that moment, when we go further through this, we get the situation that we have 2 cars discounted at a time. And this is not what should be at the end. You see, it's always important to take care about concurrency handling also on the most of the time on the business layer. And the reason why you have to take care about concurrency on EclipseStore is because of the architecture is different to the architecture of MySQL, for example. And this is what I've tried to show you here. So we have a quite common architecture of single-threaded, and most of the databases are always single-threaded. So they have a single-threaded transaction queue on inserts, updates, and so on. But in between the database itself and the clients is mostly an application server that handles the data. And you see that here there is no level 1 concurrency on the application server. So level 1 means technical concurrency handling because of each client or each, let's call it concurrent user, has its own user session at the end. So each client is operating on their own collections and so on. And that's the reason why you do not have that technical concurrency risk on when you deal with normal databases or database servers. So because it's always an isolated session, I would say. But there you have to take care about level 2 and 3, and level 2 and 3 means all that business concurrencies at the end. And on EclipseStore, it looks like this. So that means even when we have an application server with the storage in the background, and we have client sessions, of course, but at the end, all these sessions are operating on one big object model. Of course, the client sessions are multi-threaded and so on, but as I said, they are working on one object graph. And that's why it is important to take care about those technical restriction or technical concurrencies at the end. That's the reason because why we're doing that concurrency stuff in that training. Some of my colleagues would say, okay, this is not part of EclipseStore. Why are we doing this in the training? Because in my experience, a lot of developers are not aware of concurrencies. And it's for them, it's a big issue handling this because they did not know the best strategy how to handle concurrencies. And when we talk about the best practices, stuff like this, then we could search for it. And it's quite interesting, the solutions that you found. Okay, so but this will be part a little bit later. And that answers the question, is EclipseStore responsible to take care about concurrencies? Yes, especially for concurrency that happens within the API. So EclipseStore core framework is single-threaded. So it's kind of like this in the same way like a database. So there is a queue in the background, let's say, and it stores the data in a single-threaded way. So it takes care about concurrency within the framework. So each operation is an atomic one. So that's okay. That's fine. Not a big deal. But EclipseStore itself is not responsible for the business intelligence and also for your object graph. And the reason is we are not able to doing that because this is on your layer. So when you're implementing your object graph, you have to take care about concurrency on your collections. Yeah, and when you Google for it, for concurrency, you will find a lot of different tutorials and best practices and so on. And an interesting thing is the biggest recommendations are try to prevent concurrent accesses whenever you can. So that's what most of those websites are suggest to you. And they are true. Best solution or best practice is handling concurrencies is prevent concurrencies. Because when you have concurrent accesses, it's always a lack of performance at the end handling this. So best solution is prevent it. You will get the best possible performance at the end. But how to do this? First step is try to use immutable objects whenever you can. So we will talk about this a little later, what that means, creating immutable. One is using records, and that is also a question that is mostly asked for EclipseStore. Am I able to use records within EclipseStore? And I have to say yes. Does it make sense to use records? I'm not really sure. The records are a great solution within Java, but not always it makes sense having records within your entities or data structure. Records are best fit for data transfer objects, for example, but not, as I said, not always for entities within the data structure. Sometimes yes, sometimes no. It's totally up to you. A record is by default an immutable, creates an immutable object person, and you will no longer be able to change something at that person. Now you might say, okay, how to handle that data at the end? So immutable, okay, understand it, what it is. The core functionality is being not able to change a person instead of deleting the old one and creating a new one. That means whenever you want to change, for example, the email address of a specific person, you have to deal with the question, does it make sense to change the email address? Or a better example would be a book. So is it possible to change the ISBN of a book? Does this make sense? Or does that happen in the reality? Does the ISBN number of a book changes? And most of the time, you will see that it doesn't make sense to change this because the ISBN could not change in the reality. And if the ISBN changes, it is a different book. And in that case, it makes sense to have the ISBN as a field, as an immutable value. And that brings me to the next point. It's final. So the keyword final is you should always use final in a situation where you can use it. So because maybe a name is not a good option, not a good example for this, but the ISBN is. So that means ISBN is immutable and it should always be final because you will never change, you should never be able to change the ISBN. It could be an email address, for example. A release date of a book could also be an immutable value because the release date of a book will never change after it is released. It stays forever. So, and yeah, it's a little bit up to your application itself. So if you have different business needs, for example, sometimes it makes sense to change that, and it's up to you. But whenever you can, use records or use final on your objects and on your fields. And record, I would say a record is the same like when you add final to every field of your class, then it works in a way the same than a record itself. So this will help you a lot to prevent concurrent accesses. That's step number one. So whenever you can, use immutable objects. And next step would be try to reduce the amount of concurrent access as much as possible. You remember that situation I explained of heavy writing or heavy reading and then just delete one element. So, and the more you decrease the amount of accesses, the more you reduce the situation that a concurrent issue could happen. And this is quite helpful doing this. So, and that's also the reason why we use, for example, a hash map as a collection with a specific index, for example, to prevent also these concurrent accesses, because there are so many lists on the value side that you reduce the possibility that multiple persons or users are working on the same list at the end. So try to reduce the amount of concurrent accesses, and that's okay. Another aspect is using synchronized. And that's also quite interesting because using synchronized maybe you might use synchronized on the method layer. That's okay. But you could also use synchronized on collections. We will have a look at this a little bit later. This could also help. And step 2, I would recommend, and you might say, oh, hold on a second, maybe there is a step 1.5 in between, but I will also come to that. In my opinion, step 2 is reentrant read-write log. There is one framework in place which provides you that reentrant log, and I will show you a default implementation of that, and you could use it by default, or you could add some specific or some special things for your needs, but this will work best for you, I'm pretty sure. This is kind of like synchronized, but it's not that rigid than synchronized. It's synchronized logs reads from reads also, or reads from writes, or writes from reads. That makes sense. But the reentrant log differs whether it is a read or a write log. So and also the reentrant log is not tied to the code structure. That's also a big advantage. Instead of synchronized. Synchronized, it's always tied to the structure. And there are many more disadvantages of synchronized at the end. For example, this here, synchronize will not work like the FIFO order, first in, first out. So, and normally you would say, okay, synchronized works like that, but that's not the case. Synchronize is not fair. That means it might be possible that some accesses that are later than others comes first before the others. So yeah, that's some more specific stuff. And that's why reentrant read-write log is my personal favorite to use it. It works in most cases, and it works really great. And on step 3, there is the concurrent hash map, or let's talk about all the concurrent collection that are available in Java, but they have a lot of cons on the con side, a lot of cons. There are also pros. For example, the concurrent hash map, it is working basically. It's mostly thread safe, I have to say. And it's, in my opinion, the best solution when you really need concurrent or thread safe map. That's okay to use it, but you have to be careful. In some parts, it's quite slow, and the performance is not the best, but that could be okay. Having data which is not accessed that much, for example. But on the other hand, if data is not accessed that much, then you don't have to take care about concurrency, right? So this is, it's always up to you. And on top of that, there is another concurrent collection which is working okay, I would say, but it's the copy on write array list. It's also a thread safe variant of array list, but it's the same here. You have to take care about not storing that much data in and write it, because if this copy on write array list is growing more and more, it will be a lack of performance at the end. So it's quite a slow solution. And that's why this is step 3, in my opinion. So that means I would recommend using using immutable objects first, and try to prevent by splitting up the traffic a little bit. So prevent concurrency whenever it's possible, or reduce the amount of accesses to a single source if it's possible. And next steps would be reentrant read-write log, and step 3 is using concurrent collection. And last but not least, now with the GigaMap, also the GigaMap will take care about concurrent accesses, not in the alpha version, but in one of the next versions. This is a feature we are currently working on. Okay, so a lot of talking. Let's jump into the project itself to give you an idea what that means in practical cases. So there we are. Cluster demo. Concurrency. Here we are. Okay, so let's move on to the next branch. So team switch to step 1, immutable. Oh, I have to close this first. So, okay. Team switch to immutable. Okay, so let's have a look to the book itself. So, and this is what I already explained. So whenever you can add the final keyword to a specific field. So especially when you know, okay, this is a field which cannot be changed in the future, and this will make things much easier. So how about the name? Does the name of a book could change for some reasons? Mostly not. So that means the name of a book could also be final. The release date, final, I would say. If it's released, it will be the same. So how about the author? Will the author change? No, it won't. So that means the only thing which is left over is the price itself. The price could change, right? So that's the truth. So what could we do to handle this one? This is, yeah, I would say this is bad luck. So all the attributes are final except one. So how could we handle this? How could we do it differently? So let's exclude that price in a different structure. So let's create a pricing collection with let's say, maybe a key value storage of pricing. So let's say key value, ISBN, and price, for example. That could be, or you have a history of prices of a specific book. So that means a book itself. So that means it's all about your data structure at the end. So books itself are core data, I would say, or base data. Let's call it like this. And the price are, let's say, business data that could change, and it's more related to orders and to accounting, I would say, and it's not relating to the book itself. So split up these informations in 2 different entities, for example. That might help to prevent concurrent accesses on a book, for example, or on a collection of books. Okay, so this is when we talk about try to do things or create immutable objects at the end. So let's move on. Next, a branch. Switch to using synchronize. Okay, that brings me to data access logic. So, and now let me just double check if there, normally I have a list of things that I want to talk about. So that's important. So, oh, come on. So, oh boy, what's going on here? So, okay. Let me just check if there is no. Okay, not that important. Let's try doing this. Let's try doing this in the same way. So what we could do, so I try to find, give me just a second. Immutable. I need to find that class. So DB data root. Yeah, that's what I am looking for. Have you ever seen this collections.synchronized list? Have you ever used this? I personally, before I read this in a book, I've never seen that before. So that means, of course, you could add that public synchronized. No, I did it the wrong way, right? So synchronized public, does it? Synchronized public, is that the right way? Yeah, okay. You could do it like this. So that means only one thread could access that method at a time. So that could help. But as I already explained, it's not a fair mode, and it doesn't differ reads or from other reads. That means also read accesses will be blocked at the end, and that slows down your performance enormous. And that will help you to keeping things synchronized, but it will also decreases the performance enormous. So, and it's the same on this situation here. You will be able creating a synchronized list like this, but this will not differ from the reads, that will also block the read accesses, and this will also decrease your performance. But it's possible doing that, and that's also the reason why I want to share this with you. Okay, let's move on to the step 2, the reentrant read-write lock. So switch to step 2. Okay, all the stuff stays the same. So there is a data root. So we have multiple books here, and we have just one books here, but inside that books object we have multiple ones, and that's an interesting structure, I would say, that we recommend before the GigaMap was there. And you could have multiple list of books here. So it's more a lazy topic, or it's more a lazy related topic, I would say. But you could have multiple books here on different collections. But keeping these things synchronized is much easier when you use when you're using DAO classes, so data access classes. Let me just check if there is, where is my DAO class? Where is it? Let me just double check. Books delete all. Box remove random. One moment here. I have to double check what. Exercise based. Okay, here we are in the right branch. Okay, now you should see here is the data access object, and I call it data access object book. And this is what we have seen at the beginning of the training today, that extends read write locked. And this comes from another package here. And this is the default implementation I've talked about. These are the value operation and the void operation. It's just an interface, but the most important thing is the read-write locked implementation here. And as I said, this is a base implementation you could use directly. So when you check out the concurrent project, and it's also available within the GigaMap example and also on the ESMN setup, you will see that concurrent package here. And this contains one class, and it's called read-write locked. And this class is used especially on that DAO classes here, extends read-write locked. And that enables you to using stuff like this here. So for example, add books is a write operation. And that's why it is wrapped within this .write method, lambda method here. That means everything that happens here inside is marked as a write request. And clearbooks is the same, and it's different on iterate, for example. Iteration is a read operation. So, and that enables that reentrant read-write lock to separate reads from writes, okay? But all the reads can be accessing at the same time, and that increases the performance enormous. So, and this is why this is my favorite. This is not possible with synchronized, by the way. And this is why I always would recommend this before using synchronized. Okay, so feel free to use this within your project, or feel free to extend this a little bit if you need. There are only, let's say, 1, 2, 3, 4 methods or 5 methods. It's not that complicated to understand, and yeah, feel free to extend this if you want. Okay, so step 2, that was reentrant read-write lock. Let's give it a try, right? So let's run this application. So run as just a second. Where we are. Let's do a Maven update first, maybe because of the changes. So sorry, I have a little cold, so I hope my voice will stay till 9. So I run as here. Okay. There is that data which is already in place. So okay, let's try it again. Okay, application is up and running. So let's create the data. Let's call books.create. Okay, books are created successfully. And then let's call the iterate. So this is what we have done before. And now let's try to delete the book. And now you see the concurrent read-write lock is in place. And now I could delete as long as, yeah, it will never fail. So because the concurrency is handled within that method, and now this is working really great. Okay, so let's stop this. So move on to the next, to the last 2 possibilities. Switch to concurrent hash map. It's also just an example of using that concurrent hash map. So we see that here, concurrent hash map. And yeah, I think that there is no special comments on that. You could use it as every normal hash map, and it will also cover your concurrency handling, I would say, but it's not that fast than other solutions. Okay, so, and this is, I think that's important. So if you have any questions, so feel free to ask, especially for concurrency stuff. As I said, that's the only, I think that's a little bit of a trade-off. So when you use EclipseStore, you have to deal with that technical concurrency stuff, because all of your concurrent users are working on the same object graph. So that's the reason why you have to deal with it. On the other hand, you will get a really great performance from EclipseStore, and it's a different type of storage, and therefore it is ultra fast and so on. And on the con side, there is that concurrent thing. But as I also explained, if you keep the accesses, so if you don't use that heavy accessing stuff, you don't have to deal with concurrency at all, because all the single atomic operations on a specific collection are that fast that you will not having any trouble. except you have heavy writing or heavy reading on a specific collection. Then you have to deal with it. Okay, so a lot of explanations. How about you? Are there any questions so far? Okay, so no one. All of you are experts in concurrency, I guess. That's a great question. Which are the most common use case for EclipseStore? High frequent trading, maybe. Gamification, maybe. I would say there is no specific use case for EclipseStore. I think it's the same question for every database on the market. When to use a relational database? What is best practice, or what is use case for a relational database? Storing data, and it's the same for EclipseStore. Storing data. We are using Eclipse. We used EclipseStore 1,000 times before on different normal business application as a normal storage, where all the other user would use a relational database instead before. So that means we have, at the moment, we have 7 or 8 big applications on the Allianz insurance company, for example, and all of them are using EclipseStore as a normal storage instead of using MongoDB, for example, because of that eventual consistency of MongoDB. They moved to EclipseStore, and it provides such a great performance, and that's a use case, using it as a normal database. But there are other situations where EclipseStore could provide much more benefits. For example, microservices, storing stuff within smaller services instead of having that heavyweight relational database servers and so on. Whenever you need great performance, whenever you have to keep it simple, for example, your Android devices, for example, they need a database on your smartphone device. Instead of having SQLite, you could use EclipseStore to store the data in a great object-oriented way. So, or you have fat client applications on your PC. So, and you're searching for a database that can be connected, or you always have, let's say, in the past, you're using H2 database, for example, for storing data on the client side. Now you could use EclipseStore storing data on client side. That's totally up to you. So, and you could use it for caching purposes, for example. Or you could also use it for sharding your database. For example, now you have a big monolithic Oracle database, for example, and you need a better performance on, let's say, orders. Why not to cut out useful pieces of orders and maybe some additional entries and put it to an EclipseStore data provider server, and to shard your system to create micro storage entries and make your applications or your architecture more resilient to stuff like this. I think that it's an easy question with a big answer at the end. So a lot of use cases for EclipseStore. It's totally up to you when to use it. There are no big disadvantages on EclipseStore, I would say. Yeah, for example, I wanted to use EclipseStore on Android with Kotlin. That's totally okay. But I did not get it run. Maybe you have to check out on GitHub discussions with your problems. Maybe you will get help for sure. It could be only a small configuration stuff or thing, but we tested it, and we have our experts on our developers, and some of them are for sure tested Kotlin before. Okay, some more questions regarding concurrency, regarding EclipseStore. Okay, so that's concurrency. So let me clean up my ID a little bit. Next thing I want to talk about are just two smaller things, but might be really helpful to you. Two projects. One is the custom storing behavior, and one is the custom type handler. There are other customizers available, but I would say these are the two important ones. So let me share this with you. So here we are. We don't need this anymore. So let's start with the custom type handler. Okay, that is the custom type handler. And let's custom storing behavior. Is here. Custom. And there is another one. Let me also share this directly with you. It's a custom class loader. And this might be helpful. In some situations, it is needed to use that custom class loader. For example, when you use Spring projects, or when you use, come on, what is the name of that application server? Whitefly? Yes, I think a Whitefly comes with its own class loader when you start an application in it. And that makes it necessary, or that makes it necessary to adjust the class loader. But I think it's enough to have a project like this as an example to see how it works. Yeah, I kicked this out from the training because it's okay for you to see that. If you need it, just have a look to that example project. Let's talk about the type handler itself. So, and let's see when it makes sense using that type handler. I prepared a small presentation for this. Okay, class loader, just for you. Oh, just a second. Yeah, as I said, Spring Boot or Whitefly could need a different class loader at the end. And maybe this could be also the reason for Kotlin, but I'm not really sure. Yeah, just check it out. I'm pretty sure there are some Kotlin examples also somewhere. Okay, how to set the class loader? I think that's the also it's also the same within the project, but never mind. So let's start with storing behavior. Yeah, that's one situation that might be possible. Sometimes it makes sense to store something, but maybe there is something in it which shouldn't be stored. For example, third-party elements. So let's say there is one specific type or one specific class of a third-party library that has to be stored for whatever reasons, and you don't, or it's part of your Pojo, for example, but it should not be stored. Then you will be able to implement a custom company store, for example, and it prevents storing specific fields within your class. So that means you will be able to prevent things from storing, and it's the same when you want to prevent stores from storing eager, for example. So that means you will be able to define the storing behavior of a specific class by using that custom storing behavior. So this is the way how to implement such a specific storing behavior. So for example, here is the custom eager storer and the custom company storer that is created before. And this is also a configuration which is based on the foundation. This was part of the Advanced 1 training or on the fundamentals training that I explained. So I explained that most of the configurations could be based on the configuration layer, but these elements here has to be set on the foundation. So okay. Another interesting thing is the custom type handler. And that is a quite interesting thing, especially when we're talking about having heavyweight data with just a small information. So for example, when we have classes like this, so let's say we have a time slot class, and let's imagine that we have millions of time slot entries. Then you will have the problem is not the data itself, because the class itself is a quite small class with just 3 fields in it. But the real heavyweight thing at the end is the reference of each local date time and its underlying references of other elements within that local date time class. And then it makes sense to wrap up that time slot a little bit to just so that's what I explained. So each time slot entry comes with 2 and 4, and each is an object reference. And that means that the object reference itself, it's more expensive than the data in it. And then it makes sense to use such a custom type handler. And let me just show you this within the project here. So that's the time slot. That's the time slot class we talked about. And it consists of an instant, or so in the example, it was a local date time, but that doesn't matter. And now we added a special binary type handler here. And that binary type handler transforms the instant to a normal, to a long, I guess. Let me just check. So from is, that should return a long at the end. So that transfers the heavyweight instant to a primitive long, and that decreases the amount of used storage at the end enormous. So especially when we're talking about having millions of time slot entries, and then this could be really helpful to decreasing the amount of storage which is needed at the end. And I'm pretty sure you will be able to decrease 10 or more times the memory consumption at the end. And therefore, this binary type handler could be really helpful, especially when you have to handle a lot of smaller entries or entities at the end. Okay, so that means custom type handler. There is a lot more documentation within our website regarding this, but I think it's important to have an example how this works. And we talked about that storing behavior. So let me just repeat this also. There is a custom eager storer. Okay, that looks the same like in the presentation, but let me just check. If entity type equals company, okay, and the field dot get type is an array, then it returns false. That means this field isn't stored anymore, and yeah, that's okay. And the custom eager storer, so that means if this class is annotated with store eager class, so let's jump into the customer, I guess. Yeah, you see that? That means company is always stored the eager way. So even if we call a store on a customer, which is a lazy store by default, the company will be stored also. That's, let's say, yeah, a custom storing behavior to increase the store logic at the end. Okay, so we talked about this within the fundamentals and advanced one training, that the stores are different. There is some lazy storer and eager storer. And yeah, when we store only the customer with lazy, only the direct fields here will be stored at the end. And by the way, if you are able doing this, if it's possible, try to use the smaller int primitives instead of big integer reference object data types. This will also reduce the amount of RAM at the end, because we are an in-memory database, and each part that we could save will increase our performance at the end. Okay, so instead of using integer, if it's possible, use an int. I know it's not always possible to do this, because of sometimes it needs to be like this. This will not be possible when we use the primitive. So, but it's okay. If it's possible, it being null, I think that's the point. So yeah, now I'm right. So an integer could be null. So, and that's the difference, I would say, but it's much more heavier than the primitive one. Okay, so let's move on. Last but not least, so we talked about the customizers, and they are really straightforward. So any questions regarding the customizers? To be honest, I'm not used them that often. Sometimes it makes sense using them, but most of the time we are good to go without them. So that's okay. Okay, good. So let's move on to the last topic for today. And I think we have enough time to go through a little bit bigger presentation I prepared. Let's go to the cluster part. Let me just check my presentation. So okay, this is not the right one. So just a second. Anyway, let's start on this. That's okay. So okay, here we are. So we will skip some let's say charts of that. We don't need it anymore. Okay, so normally when we talk about clusters and so on, we mostly, there must be a reason for using clusters or using replication or sharding or whatever. And in my experience, there are a lot of situations when I talk with people, and maybe you also, just a question to you. Does any one of you uses clusters or clustering now? That might be interesting too.
Yes, we are.
Mm-hmm. Why do you use clusters? What is the reason for this?
Performance, responsibility, and so on.
So you have a replication in place, right? So, and
yes.
There is a load balancer in front of, and it routes you to get the right response time. Okay, I see. And this is this what you build by yourself, or you get this by default from a specific product? So maybe let's give you an example. Using Redis, for example, provides you a pre-configured clustering out of the box?
No, we use Hazelcast.
Okay. Yeah, it's the same. I would say, okay, it's nice to see that. But there are a lot of persons who are using clustering, and yeah, they don't really know why they use it. They just use it because it's embedded and it's built in, and they use it for this. And most of them are not aware of how complicated clustering really is. And let's wrap up this a little bit. So let's talk about. So let's talk about a monolithic application. So it is basically working great for a lot of nowadays. So there are a lot of monolithic applications on the market, and most of them are, yeah, they are okay with that. Easy to deploy, no specific infrastructure needed. Most of the people are able to maintain, and it's easy technical vertical scaling, right? So nothing special on that. By the way, what do you think? When we talk about vertical scaling, that means we scale infrastructure, right? So we're scaling pods to a specific amount of RAM or CPU. What do you think? What is the biggest EC2 instance, for example, from AWS that you can, let's say, rent? So what do you think? Just type in some guesses from you. Biggest RAM and CPU sizes you could get from AWS. Not Googling, right? So just guess it. So to give you an idea, so this is one example. So I find, so it's let me just check. This is the wrong one. Where was it? Come on. Just a second. It's the wrong. Come on, where was it? So, okay, it doesn't matter, but I could remember the amount of RAM is 32 terabytes of RAM with 846 CPUs. That's insane. So yeah, sometimes vertical scaling is totally okay for a lot of people. That prevents you from the complexity of a cluster for sure. In some cases, it makes sense staying on vertical scaling because, yeah, resources are there and can be used at the end. So, but of course, you are right. There is no
Java heap space are maintainable on some value. Yeah.
Yes, of course. Yeah. But on the con side, there is no horizontal scalable possible with that monolithic application because most of them are stateful applications. And yeah, that's a big issue. And on the other side, there is not only scaling is an issue, it's also fail-safe. There is no possibility for fail-safe, and there is no high availability. And fail-safe means that keeping the impact as small as possible if something fails, that means fail-safe. It doesn't prevent you from failing, but it keeps the impact as small as possible. And high availability means keeping the response times within an acceptable time frame, even if we have an enormous amount of accessing the servers, for example. So that means high availability. Okay, so let's move to the next step. So we could build things like this. So so that means we could separate this in different layers. So that means we have a JVM here with EclipseStore. It's a REST provider, right? So it provides the data via REST. So this is also the answer when people asking me how to accessing EclipseStore data from multiple different applications. And that's exactly what I recommend always, creating your own database, let's call it like this, based on EclipseStore, based on Java, and provide the data via REST. It's 1,000 times better than accessing one Oracle database in the middle from different clients. So anyway, let's move on. So then we have one REST provider that provides the data, and then we have in the middle we have a JVM, RAM, and some business logic. So let's call it application server, and then we have a UI, right? So that's a more advanced deployment at the end. There is a lot of more technology is ongoing. So we need different UI technologies. We need Spring or Helidon, Micronaut for the different layers here. But it's not fail-safe at all. It's the same problem also here. And there is no high availability on layer 3. But on layer 1 and 2, yes. So we will be able, for example, here on the UI, we are able to replicate this UI layer as long as it is stateless, right? So at the moment when the UI becomes stateful, then you will not be able to replicate the easy way anymore. So therefore, I would say it's still a monolithic application because, yeah, it's a very traditional architecture, I would say. You could using a queue, right? So instead of, let's jump back on this side here, on this layer. So there is an issue on layer 3 based on fail-safe and high availability. But we could add a queue in between. So that means when some containers or some applications are not available anymore, we could queuing the reads and writes. And this is what, by the way, is done 1,000 times before, especially that's also the reason why for using Kafka or any other queuing frameworks in between microservices, because you don't have to take care about is it available or not. It's all handled by queue or by Kafka, and each consumer of the data will consume it when it's available. So that's the point. And this provides us the fail-safe, right? So because systems are working even if the partner is not available, because it writes the data to the queue and it didn't take care about what happened next at the end. But there is still no high availability, and that's exactly the point. And this is, by the way, the same situation you explained to me. I don't know who is talking 5 minutes ago about clustering and so on. That's exactly the point where you need high availability, because you will be able to replicate your cluster, your nodes, to providing the data to a huge amount of concurrent users, for example. And that's exactly where replication is made for. And it looks like this. So replication, it provides fail-safe, high availability, load reduction, efficiency, and so on. But on the other hand, it's highly complex, data loss, data inconsistency, maybe multiple servers, and it's mostly not doable for most of us. And even me, sometimes it's quite difficult and challenging to creating an architecture like this. And that is the reason why most people using fully managed systems. And that brings me to EclipseStore Cluster as a Service. And this is what I want to talk about a little bit later. So, and there are many different types, many different knowledge that you have. We're talking about async and synchronous replication, the type of architecture, single leader, multi-leader, no leader, and so on. And yeah, there is many more things to need to create a proper clustering and cloud. And this is exactly the idea behind the MicroStream Cloud Cluster thing, a central point for hosting your application, not only data provider, also clustering other things. So that means you could provide us a single application and we doing the clustering or the replication for you, as long as you stay within a specific yeah, you're moving between specific rules within your application. But I will come to this later. So this hides you from the complexity of dealing with security, Helm, and Kubernetes, and so on. And it provides you monitoring, logging, backup, everything out of the box. And it's kind of like a fully managed Kubernetes configuration out of the box. So that was the idea, or that is the idea behind. So how does the cluster work? The basic answer is standardization, because when we see all the different major things on a specific application, so let's say a basic application structure, so a basic microservice framework, we could use Micronaut or Helidon, and all these frameworks are quite standardized. So they are working mostly the same because they are tied to other external standards, and that's why mostly they are working the same. Let's talk about REST. REST is in the same way standardized like these frameworks, so it's mostly the same. And a big benefit for us is EclipseStore is a standard framework, and it's on us to support it and make it usable for the future. And we are able to support the cluster at the same time. And that brings us in a situation that we are able to, we could say, okay, if you created an EclipseStore storage based on Spring, Micronaut, or whatever, using REST at the end, and if you're using a special a cluster storage manager, for example, then we are able to clustering and replicate your application out of the box without any changes of your application. And that's the idea. So let's have a short look. How does it work at the end? So, okay, let's start on our cloud platform. So when you first log in to our cloud platform, you will see a welcome screen with different informations and so on. And when we go to the starter page, you will be able to download a specific base framework. So you could start on Spring Boot, you could start on Micronaut. Helidon is still work in progress now, so they did some changes and we have to modify these changes. But Micronaut and Spring Boot is provided, so that means you will be able to download a specific, let's call it template, to your IDE. So it's working the same way, let's say, like Micronaut launches works. It's barely the same. That brings you in a situation when we jump into the IDE. So that means you will get an application that looks like this. So just a second, need to find it. Here it is. So cluster demo. And when we have a look at this, it's just a small example application that I created a few years ago, but I use it and I updated it all the time. And you see that it's totally based on the things we talked about. The only difference here is the cluster storage manager. That's the difference because the storage manager itself has to talk or has to take care about replication at the end within the cluster. And that's why we need a specific cluster storage manager at the end. But all the other stuff stays the same. So that means we have our controllers here with get and patch and so on and update and whatever else you need, insert your REST endpoints and so on. So you could use it as you want. So it's totally, let's say it's standardized. It's always the same. And there is another aspect which is quite interesting. Some of you already have those applications, those data providers and so on. And maybe sometimes it comes to a situation where you say, okay, now we need a replication. So we try to find a way to replicate that. Just feel free to change the embedded storage manager that is used before to a cluster storage manager and provide this to our cluster. And this will work, I would say, mostly out of the box with clustering, as long as you stay in between, also within a specific rule set. Okay, normal domain classes, nothing special. It's always the same. And you will need one class. It is like this. It provides the storage manager to our internal cluster handling. So that means our replication is able to get information from your application, and that's it. So that means you create your data provider as always, as you are used to. And after that, that brings me back to the UI of the cluster itself. So then it starts here on the cluster side. So every cluster consists of two specific parts. The first part is the platform itself. So the platform itself is tied to the region of, for an example, AWS here. But later you will be able to create your cluster also on Azure and Google Cloud. But for the moment, only AWS is provided. And as you can see here, a platform itself is tied to a specific region, and of course to a specific a cloud provider. And on the technical side, it's an AWS managed Kubernetes service. And that's the platform. And as you can see here, there is one platform already available here. It's on the region EU Central, Frankfurt, and you need that platform. So on that platform, you could have multiple different clusters. And that brings me to the right side here. So we could say add cluster. Now you choose the type of application you created. And then you choose a cluster base tier. The base tier is, let's say, the basic infrastructure that handles your replicated pods in the background. So that means the more pods you have, the more heavyweight writing you have, the more powerful your base tier must be. So, and that's the reason why we have a small one, which could handle 1 to 2 nodes with a maximum amount of 160 gigabytes of data, of storage, and medium up to 5 node counts, and large up to 10. That's the base tier range. So let's select one. And now that brings me to the storage nodes. So that means to the replicated nodes. And now you could see there is micro, small, and small one. Let's choose one. And now you could set the minimum amount of nodes you want to have and the maximum. So because the cluster itself raises up some nodes if it's needed, and there is an auto-scaling function in place. So and you only have to pay for the amount of node currently up and running, not for the maximum. So that brings me to the next screen, provisioning. So you will be able to add a cluster name and provide us the information how to provide the project. So it's kind of like working like AWS Lambda. So you could provide a jar also, but you could also add a repository URL, and we will clone the project from your repo, and we will build the project in the background, and that's automatically made for you. Let's say a cluster name, let's call it whatever, doesn't matter. We need a URL. So give me just a second. Let's choose the project from GitHub. Okay, so copy this. So let's add the URL. Let's choose the main branch that we need. Let's click on next. So now we can set up a specific backup strategy of your data. So once a day, twice a day, 3 times a week, 2 times a week. It's totally up to you to choose the right backup strategy. You could add a cluster authentication. So that means when you access your REST endpoints, you could choose, for the moment, basic is the primary one, but we are working on this to creating more extended ways to authenticate. And there is also the possibility to create an AWS private link. So having a private link connection to our cluster at the end. And that, just an explanation for you, that prevents data accessing the public internet. So that means when we establish that private link, it's kind of like having this private link directly in your AWS infrastructure without touching the public internet. Okay, some proxy settings, and these settings are important ones. These settings handles the traffic, or how the traffic is forced to the writing or reader nodes. So our cluster is working based on the single leader architecture. That means there is one writer node and multiple, let's say, infinite readers. So, and now we have to separate the reads from the writes. And this is how exactly it is configured. So it could be based on the specific HTTP methods. So that means delete, post, patch, and put will always be forwarded to the writer nodes. But it could also be based on a specific URL path. That means add a specific keyword or a specific path to your URL. And that means, for example, edit customer. And this will, all the traffic incoming based on that path will lead to the writer nodes. And a third could be some specific header values. That means, for example, you could add the write request to your header, and that will force the application to lead that request to the writer node at the end. So I'm good with HTTP method, that's okay. And last but not least, you will be able to upload an already existing storage, and that's it. So after that, you could click on create, and you will get just a template. It's provisioned, but it's not started so far. And because of that takes a little bit to set this all up. That's why I created an already running one. So that brings us to the situation where we can see the details of that cluster. And before we get further into it, let's jump back to the presentation. Just to give you an idea of how the architecture of the cluster is. So this is the architecture diagram of the cluster. So that means, as I already explained, there is one load balancer right before the cluster itself, and it separates the reads from the writes. So, and you see that here we have one writer node, which is the left one here, and we have two reader nodes. Each node has its own storage. That means that's the way that, because each element here is a single storage, let's call it like this, and it's replicated so by the event streaming platform. For the moment, we are using Kafka for streaming the data to all the different nodes. And yeah, so that means when we having a read request to a specific client, read can go to every single node within the cluster, and you will get the data at the end. And if we talk about a write one, it looks like this. So the write one goes to the load balancer. It will be forced to the writer node. The writer node stores it to its storage, and it goes to the backup part and to the event streaming platform, and it will be replicated through, let's say, Kafka or any other event streaming platform to the different reader nodes. This is how the cluster basically works. Let's jump back to our cloud. So this is the detail page. We are currently working on the layout on that page, so it will be improved a little bit, especially the lower part here, because sometimes it looks a little bit confusing, but we are still working on this. So up here you will see the pods, and also the RAM and the CPU usage of your pods. You see the URL to connect, and some configuration stuff is ongoing here, and also proxy configuration is you are able to change all your settings and so on. And you will get also a monitoring, so seeing what's going on on your different nodes. Let me just double check. Now you see this is the amount of memory usage and bandwidth and so on, and throughput. And there are some more metrics that we are working on. And it's the same on the logging side. You see all the logs that happens on different nodes and proxies and backups and so on. And as I said, we still working on an improvement here. Will be available somewhere next week to getting a more and better overview of all logs and monitorings at the end within the cluster. Okay, so let's summarize that a little bit. Here we are. So what we created is, or what features that we provide now. So we provide an AWS cloud platforms. As I said, we're still working on Azure Cloud and Google Cloud. Supported frameworks are now Micronaut and Spring, and we are also working on Halidon, but it's almost done. It's just some smaller improvements to provide this again. Supported deployments are JIT and jar upload, and we are also working on kind of like a Jenkins integration and to creating deployments for your CI/CD platforms. We support individual tier sizes and so on. There is an auto scaling, which is already in place. Basic authentication, we already talked about private link. I think that's one of the most important things, that you will be able to bind this to your already existing AWS structure. There are individual backup strategies, and yeah, individual routing strategies, monitoring, logging, and so on. There is a roadmap. We already talked about this. The supported frameworks is already in place, so I can cancel this here. But yes, we talked about. And for the big picture, there is a big data cluster in the pipeline, so we will see what happened in a few days, weeks, or months. Okay, and the good news is this whole cluster is also available as an on-premise cluster. So of course, this is a SaaS system, so software as a service. But as always, most of you or some of you are not able to move the data to a third-party company, for example, and therefore we created an on-premise version of that cluster that could in different ways, and this is handled kind of like a let's say service that we provide to you. So it always depends on your already existent, let's say, Kubernetes infrastructure, and it's always a service that we provide you to set up a cluster like this on your internal infrastructure. So if you are interested in that, let us know. Then we could provide some documentations and so on to you to make it happen. So let me just say a coupon code at the end of the slide is what. Oh, sorry, that was an old one. That's an old information of I guess. Let me just double check. I have to remove this from my presentation, or is it? Am I right? So let me just double check this. Did I close the? Just a second. Let me just double check this. I think it was an old one. Yeah, it's an old one. It's an old coupon code. So It will be possible getting a coupon code for testing that platform. Let us know if you are interested in. Yeah. Okay, so that's from my side regarding the cluster. How about your questions now? There is one from Frank. What is with Strato high drive as cloud? Could be possible. We have to evaluate that because we need some special things already in place. For example, the Kubernetes infrastructure and also the API. But as you said, it's the same command structure as AWS. That's great. So we have to check, yeah, that maybe it should work also on Strato high drive. Let me take a note of that. That could be interesting. If it's the same command structure like AWS, and if they have the same infrastructure in place, it could be not a big deal doing that on Strato high drive. So let's see. Yeah, thank you for that. Okay, some more questions. Yeah, for sure it is. For sure it is. So last but not least, I missed one topic on my list. It's the topic regarding the shutting down a storage or handling EclipseStore on Kubernetes pods or Docker containers. That's an important. There are two things that I want to mention because of sometimes it's handled the wrong way. The first point is the topic of handling backups of EclipseStore. At the end, when we have a short look to a specific storage like here, so let's show this in System Explorer. So at the end, you will see this is the data, and it consists of one channel file. Yeah, in that case, it's empty, but I think you have the idea. It's easy to think, okay, just create a copy or clone it via Kubernetes. I will not recommend this. Please don't do this. Please do not use any external functionality to create clones of your volumes, for example, for creating a backup. Because you never know if EclipseStore is writing data in exact the same moment that you took the clone, and this will lead to a destroyed binary at the end. So this is a very important point. Please always use the embedded backup functionality of EclipseStore. There is an embedded, or there is a provided full backup API call, and you should always use this for creating backups of your storage. That's quite important doing this, because we had some customers few months ago. They created it via Kubernetes clone. It worked, let's say 16 or 70 times, and the 71 times destroys the storage, and that's a big problem. Okay, that's point number one. And point number two is how to call it. Sorry, I have to double check my presentation. It's called gracefully shut down. So it's always a topic. What means gracefully shut down? You always have the chance to kill your Kubernetes pods, and most of the time this will work okay, I would say. But please take care about giving your application a chance for shutting down gracefully before you kill the pod. I think a gracefully shutdown is not only a topic for EclipseStore, it's a topic for all Kubernetes or for all Docker applications you have to take care about. And it's the same on EclipseStore. So whenever you have the chance, saying, okay, let EclipseStore shutting down in a proper way, that will lead to a much more stable version at the end. Maybe in some rare cases, a not gracefully shutdown could harm your storage. It's a quite rare case, but it could be possible. So whenever it's possible, try to implement a gracefully shutdown for your EclipseStore instance. Okay, and I think that these that backup thing and also the gracefully shutdown are two information that could quite helpful to you whenever you use EclipseStore at the end. And that brings me to the end of the Advanced 2 training. So as I said, we are not that much people, quite more or less question than usual, and but it's okay. So we have enough time to have some further question from your side, but from my side, I'm finished. I think it's enough information for one training. Yeah, it's up to you. Your questions. Ask as, yeah, whatever you want. It's your turn.
Hi, Christian.
Hi.
I did some research on the costs of S3 kind of like storages.
Okay.
And like Synology seems to be the cheapest of them all. It would be great if you do some investigation on that.
Okay.
That would be really nice to have that functioning.
Okay, that brings me to it's the same like yeah, I know. I let me take a note. So I knew that I promised that many times before that I want to investigate here to that storage, but I don't have enough time to do that. But yeah.
please check the Synology functionality. It seems to be the cheapest.
Okay, great having this. So just a second, Synology. So as an S3 alternative, right? So
yes.
Okay, got it. Yeah. Thanks for the advice. So really great. Marcus, you could also ask questions, of course.
Hi, Christian.
Mm-hmm.
Is there an idea to extend the RapidClips IDE for more support of this framework?
Do you have any preferred extensions on that? So,
and my idea is with RapidClips, I can import a database and create DAO classes. And this creation of DAO classes, you can switch to MicroStream, and so you can migrate easier from an old database to MicroStream Eclipse storage.
Yeah, you're totally right. So this is in fact we have at the moment we have 1,000 ideas how to extend or improve the RapidClips IDE in a direction for handling for a better support to EclipseStore. It's always the lack of time and persons. So, but be sure that we will bring something in the future. But yeah, for the moment, I'm not able to promise anything. So,
okay, thanks.
Okay, so in the case you have some further question, please stay in the call. But for all you guys that are fine with all that stuff, I would say thank you for joining or staying with me that evening. It was a great pleasure for me. Hopefully it was an interesting training for you. And so if there are any improvements from or suggestions from your side to improve the training or any other things, just let me know. Let me share my email address. So c.kuemmel@microstream.one. So if there are any questions or suggestions, improvements, or something else, let me know. Otherwise, please visit GitHub discussions for technical questions, also for technical features. And always remember, EclipseStore is open source. So if you need support for as a contributor or contributing things, it's totally up to you. There are many improvements in the pipeline, like let's say encryption and so on. It would be great for having you as a contributor to increase the framework. And yeah, okay. So from my side, let's say thank you for joining. Have a nice evening, have a nice weekend or week, and see you next year, maybe in one of the other trainings. Thank you very much.